Meaning of differentiation. Differentiation is a process in calculus used to find the derivative of a function. A derivative shows the rate of change of one variable with respect to another variable. In simple terms, differentiation measures how quickly something changes. It is also used to determine the slope of a curve at a certain point on a graph. Differentiation is important in many fields such as mathematics, physics, engineering, and economics because it helps solve problems involving motion, growth, and change. Example, y equals to x to the power of 2, derivative dy dx equals to 2x. This means the rate of change of y depends on the value of x. Techniques of differentiation. There are several techniques used in differentiation depending on the type of function involved. Each technique has its own formula and method for solving mathematical problems. So number 1 is power rule. The power rule is used for functions involving powers of x. In this technique, the power of the variable is brought down to the front and then reduced by 1. The formula is d dx x to the power of n equals to n x to the power of n minus 1. For example, d dx x to the power of 3 equals to 3x to the power of 2. Second, constant rule. The constant rule states that the derivative of a constant number is always 0 because a constant value does not change. For example, d dx in 5 equals to 0. Number 3, constant multiple rule. The constant multiple rule is used when a function is multiplied by a constant number. The constant remains the same while the function is differentiated normally. For example, d dx 4x to the power of 2 equals to 8x. Number 4, sum and difference rule. The sum and difference rule is applied when functions are added or subtracted. Each term is differentiated separately before combining the answers. For example, d dx x to the power of 2 plus 3x minus 2 equal to 2x plus 3. Number 5, product rule. The product rule is used when two functions are multiplied together. This technique involves differentiating both functions separately. The formula is d dx uv equals to u multiply dv dx plus v multiply du dx. Number 6 is quotient rule. The quotient rule is used when one function is divided by another function. The formula involves differentiating both the numerator and denominator. The formula is d dx uv equals to v multiply du dx minus u multiply du dx per v the power of 2. Number 7 is chain rule. The chain rule is used for composite functions, which are functions inside another function. This technique requires differentiating outer function first and then the inner function. The formula is d dx ftx equal f prime tx multiply d prime x. For example, d dx 3x plus 1 the power of 2 equals to 2 multiply 3x plus 1 multiply 3. Number 8, trigonometric differentiation. Trigonometric differentiation is used for trigonometric functions such as sine and cosine. Example, d dx sin x equals to cos x. d dx cos x equals to negative sin x. Number 9, exponential and logarithmic differentiation. This technique is used for exponential and logarithmic functions. These functions have their own special differentiation formulas. For example, d dx e the power of x equals to ex. So for conclusion, differentiation is an important topic in calculus that is used to measure the rate of change of a function. There are many techniques of differentiation, including the power rule, product rule, quotient rule, and chain rule. Each technique is used for different types of functions and helps solve various mathematical and real-life problems.
I just had to let you know you're
The original problem for question 2a is we need to find dy dx and simplify for the function. The function is y equals to 3x to the power of 2 cos x plus 2. Setting up the product rule formula is by dy dx equals to u v prime plus v u prime. This is because the function is a product of two separate terms, which is u equals to 3x to the power of 2 and v equals to cos x plus 2. The product rule formula is written out to guide the differentiation process. Specific functions for u and v are substituted into the product rule template. The notation dy dx used here in place of d dx. We will get 3x to the power of 2 times dy dx cos x plus 2 plus cos x plus 2 times dy dx 3x to the power of 2. Derivative of cosec theta is negative cosec theta cot theta. It is because the inner angle is x plus 2. The chain rule requires multiplying by the derivative of the inner functions, which is dy dx x plus 2. The derivative of the algebraic term 3x to the power of 2 is found using the power rule, which yields xx. The derivative of the inner functions x plus 2 will, with respect to x, is evaluated, which simplifies simply to 1 since d dx x equals to 1 and d dx 2 equals to 0. And we will get gx to the power of 2 times negative cos x plus 2 times cot x plus 2 times 1 plus cos x plus 2 times 6x. The first massive group of terms is multiplied together, pulling the negative signs out to the front. The second term is cleaned out by moving the algebraic factor 6x to the front of the trigonometric function. And we will get the equation of negative 3x to the power of 2 cos x plus 2 cot x plus 2 plus 6x cos x plus 2. The terms are rearranged using the commutative property of addition so that the positive terms 6x cos x plus 2 comes first, making it easier to read and factor cleanly. The great common factor GCF is pulled out both terms to achieve the fully simplified final answer. Both terms share a 3x and a cos x plus 2. Factoring those out leaves a 2 in the first position and nx cos x plus 2 in the second position. And the final answer will be jx cos x plus 2, 2 minus x cot x plus 2.
The original problem asks to find dy dx for the equation y ln 3x minus e power of 2x plus 1 minus tan 4y equal to 0. The differential operator dy dx is applied individually to each term across the equation. The product rule will be required for the first term y ln 3x because it is a product of two functions, while the chain rule will be required for the remaining term. The first term is expanded using the product rule dy dx equal to uv prime plus vu prime. The exponential and trigonometric terms are expanded using the chain rule, leaving the differential of the inner function to be evaluated next. The differential of ln 3x become 1 over 3x times 3. The differential of 2x plus 1 is 2, and the differential of 4y with respect to x is 4 dy dx due to implicit differential. The new equation after the differential will become y times 1 over 3x times 3 plus ln 3x dy dx minus e power of 2x plus 1 times 2 minus z power of 2 4y times 4 dy dx equal to 0. The constant and variables are simplified and rearranged for clarity. In the first term, the 3 in the numerator and denominator cancel out, simplify 3y over 3x down to y over x. The terms containing dy dx are kept on the left side of the equation, while the non-dy dx terms are moved to the right side by applying inverse operation. After we do rearrange, it will become dy dx ln 3x minus 4 dy dx z power of 2 for y equal to 2e power of 2x plus 1 minus y over x. The common factor dy dx is factored out from both terms on the left side to separate it from the rest of the expression. For the last step, both sides of the equation are divided by the factor expression ln 3x minus 4z power of 2 for y to completely isolate and solve for dy dx. So for the final answer, we will get dy dx equal to 2e power of 2x plus 1 minus y over x over ln 3x minus 4z power of 2 for y.
First of all, we have to find the equation for fx. For this question, we can find the fx with replacing the number 63.99 with x. So it will be fx equal to square root 3 of x minus 2 over square root of x. Next, we have to find the differentiation of fx. From the equation, we have to make the square root into the power. So it will be x power of 1 over 3 minus 2 over x power of 1 over 2. Then we have to bring the power to the front and it will be turned into multiple, and then we have to minus 1 the power just like in this video. And then we will get this equation. Now we have to find XO. We know that the x is 63.99, so for XO we will have 64. When we have both of the value, we have to find the x by doing calculation x minus XO. After we find everything, we can now put it in the equation, which is fx equal to fxo plus f prime xo multiple dx. We just have to replace what we find at above in this equation and it will be like this.